Let's have a look at this particularly tricky problem here. Let n equal 60 factorial plus 55 factorial plus 50 factorial. The unit digit of this number n and a number of digits to the left of the unit's digit are consecutive zeros before we come to the first non-zero digit. How many such consecutive zeros are there until the first non-zero digit? Just to review what factorials are about, that exclamation point there, what that's saying is multiply whatever number, so 60, by every integer down to 1. So for instance, if I had the number 4 factorial, what that's saying is take 4 times 3 times 2 times 1. So what this problem is asking us to do is add 3 huge numbers together. And how big are these numbers? Well, just to kind of give us an idea, let's start writing it out. 60 factorial is 60 times 59 times 58 all the way down to 1. 55 factorial means 55 times 54 times 53 all the way down to 1. And 50 factorial is 50 times 49 times 48 all the way down to 1. Now, I do know that all 3 of these numbers are going to end with a bunch of zeros. How do I know that? Well, look at this, right? 50 ends with a 0, and I'm going to multiply it by a bunch of other numbers. If I have a number that ends with 0, like 50 or 10, and I multiply it by another number, the resulting number will end in 0. And then I'm going to multiply it by 40 and 30 and 20, all the way down the line here, right? But not only the zeros, I also have 5s and 2s. So if I multiply a number that ends with 5 by a number that ends with 2, like 25 times 12, that is also going to create another 0 for this number. So let's just make this general and say that this is a huge number with a lot of zeros at the end. And this number, 55 times 54, has a few more multiples of 5 and 2, so it's going to be an even bigger number with more zeros. And finally, 60 times 59 times 58 is going to be the biggest number with the most zeros. So let's scale this down a little bit. Let's see what happens when we have a situation like, I don't know, 1,000, 10,000, and 100,000. If we were to add those numbers together, what would we get? Well, we'd get 111,000. How many zeros does that resulting number have? Well, it has 3, the same amount as the smallest number here. And that is key, right? It's key to note that the smallest number, when we're adding these 0 numbers together, determines how many zeros the final sum has. So really, we just need to focus on this expression right here. We don't need to worry about these 2 bigger numbers. What I want to focus on is the number that has the least number of zeros. So what I'm really asking here is, how many zeros does this number have, the smallest number, 50 factorial? Well, to approach that, let's think of this. What makes a 0? So, for instance, if I had the number, I don't know, 4,000, each 0 represents a multiple of 10, right? It's 4 times 10 times 10 times 10. So I can say that there are 3 10s, essentially, that make up this number. But let's go even further. What makes a 10? Well, that results from multiplying a 2 by a 5. So every time I multiply a 2 and a 5 together, I get a 10. And therefore, a 0 is added to the number. So let's think of this. How many pairs of 2 and 5 are in this number here? If I broke every number in this list down to its primes and started pairing the 2s and 5s off, how many pairs could I make? Well, I could have a lot of 2s, right? This is a multiple of 2, and 48 is a multiple of 2, and 46 is a multiple of 2. I have more 2s than I know what to do with. So really, the limiting factor here is 5. Every time I have a 5, I'll have a 2 to match it with, and that will give me a 10. So what are all the multiples of 5 in this list? Well, I've written them out right here. Here they are: 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. And let's see, if we break these down into their primes, how many total 5s there are here. Well, 5 is just 5, right? 5 times 2, well, there's 1 5. 5 times 3, that's another 5. 5 times 4, that's another 5. 5 times 5, okay, I have to double count that one. That's 2 5s. 5 times 6, another one. 5 times 7, one more. Times 8, times 9, and 5 times 5 times 2, right? 50 is 25 times 2, so I have 2 5s in here, meaning that I have to count that twice. Let's count them up. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 5s that I can pull out of this number, which means I can match them with 12 2s, which will give me 12 zeros. The correct answer to this question is 12.